Hey everyone, how's it going? I'm Shahab and welcome back to the series on building AI-powered agentic geospatial applications. In this video, I'm going to just go off-road a little bit and there will be a lot of discussions about how AI can help us, what are the tools, and what are the best practices when using AI for developing geospatial applications or just doing some geospatial tasks using AI. So there will be several videos in this series and I'm gonna publish them in between the development that we are doing throughout this series. As you know, there are lots of language models out there and sometimes it's confusing which one we should pick, which one is better for what we do. And we have to, for some reason, use different sets of these models. We have to combine them, and then for some specific tasks we need to choose this model, for others this model. But there's no a single rule saying that this is the best model and you don't need any other model. It depends what we do. There are open source and commercial ones, as you know, and the most commonly used open source or most popular ones are Meta Llama, Google Gemma, DeepSeek, and Qwen. And these are all great models. And when it comes to choosing them for what we do, I would say that the best way is to just try them and then see if that specific model is better for most of the things that you do. So Llama is very, very popular, as you know, and they have recently released the fourth generation of this model, Llama 4, and this one has three types or three models, and the smallest one, which is I think the most interesting maybe, which is the Llama 4 Ska. It has a leading 10 million context length, so it's huge in terms of the context window, which means that the content that you can send it to, and it means that many code bases, they can fit within that 10 million context window or context length, which is interesting. It means that if you have an app, you can just send the entire app, the code base into it, and then review it, change things, find bugs. It's amazing. However, based on the different tests that you can see also out there, and I've also tested them, I believe that the longer the code is or the content that you send to these models, the quality or the accuracy of the results and the responses that you'll get would degrade. So this is something that we need to take into account when, for example, sending a lot of content to these models. So Llama is really good. I've tested that, compared it with Llama 3.2 and 1, and it's quite good. So again, in a future video, I'm going to test all of these models for different applications, maybe a live video. Another one which is really popular is Gemma models by Google, and they're also quite good. These models are small. Of course, they have different quantizations, but both Gemma and the Llama 4 are natively multimodal, which means that you can process both text and vision, which is amazing. There is a video on YouTube, I think that you can find it, where the researcher, I think that from NVIDIA, they test Gemma 3 on a Jetson, NVIDIA Jetson, which is an embedded device, and it runs very, very good. So that person sends an image to the model and then queries the image, asking about different things in the image, and it's interesting. So check out that video. I'll try to find the video and then put it in the comments or the description of the video. And another very popular and powerful model in this open source AI list or large language model list is Qwen, and Qwen 3, which I think that was introduced several days ago. I think that 4 days ago or 5 days ago. And the benchmarks are actually interesting and you can see them. so I'm not going to talk about them, but very, very close to Gemini 2.5 Pro, which is a commercial one, and also is beating the other open source large language models, including DeepSeek. So check out this model. I will also test this model. And there's also the very well-known DeepSeek model. And they have, with the version or R1 or version 3, I think it introduced a new paradigm in developing very efficient models based on reinforcement learning. So read their papers, read how they did that. It's a very interesting and a smart way of training models and making sure that you can efficiently train them. And then in their new version, they have made the model more efficient for inference. So for the commercial ones, we all know OpenAI, GPT models are very well known. Google Gemini, especially Gemini 2.5 Pro, which is really powerful for many things. I personally use Gemini models, and specifically Gemini 2.5 Pro. It's really good for finding small things, for example, finding bugs in the code base. And I don't use OpenAI models these days, to be honest, but I'm gonna use them more. And then there is Cloud Sonnet 3.7 from Anthropic, which is really great for designing, UI design, and also for maybe making some changes in your code. We use Anthropic Cloud Sonnet 3.7 for designing some parts of our products, and also for new features. But these days for new features we mostly use Gemini. And then the XAI models, Grok, I don't use them that much, but they are really good. I have tested them a lot, to be honest, but for development I'm not using them that much these days, because I think that the other models are good enough for what we do. And for OpenAI, I'm gonna try more like O3 and O4 Mini. But the good thing about AI models, open source ones, is that you can fine tune them on your own data and then make them more powerful for what you do or more accurate. There is a video that I'm gonna record later, and we're gonna fine tune these models for some applications. So that's gonna be interesting. I mean, when I say applications, I mean in the field of geospatial data science, and see how, fine tuning them would increase or would improve the accuracy of these models for what we do. Using these AI models, we have seen that our productivity as humans has increased, and it's really good. It's really relieving, because we used to spend a lot of time when it came to doing some very basic tasks. And the current state is that we use AI models or these language models for example, sending emails, for reviewing long tasks, for summarizing, for a lot of things, and that's great. And then there are discussions about the coexistence of humans and AI in the future, and how we would use more advanced models or super intelligent AI models, which sometimes are called AGI. And there are also discussions about the future of human intelligence, as I will discuss, and that's also interesting. And there are some concerning parts in that I think that many people have raised those concerns long time ago, but this is something that we need to consider when working with these models, especially in the future, because these models are going to be much more powerful. As I said, super intelligent models. They are not super intelligent yet because they can't, do discoveries. They can't devise new things, new solutions. They just can do predictions based on some previous information that we provide for them. But in the future, we'll see these models perhaps will be able to do discoveries. The question is, how can we stay competitive, given the fact that these models are doing a lot of things, already replacing some jobs. An interesting paper that I really recommend you to take a look is this paper, which was published by researchers from Carnegie Mellon University and Microsoft. And the paper entitled "The Impact of Generative AI on Critical Thinking, Self-Reported Reductions in Cognitive Effort and Confidence Effects from a Survey of Knowledge Workers." This is an interesting paper. There are a lot of interesting things discussed in this paper. I really recommend you to not read everything, but maybe at least a summary of what are the things that were discussed in this paper. The researchers in this paper raised a very important point that we need to use these models. Of course, they make things easier for us, but we need to make sure that we validate things. And we still are in the loop. And without checking, it means that we don't learn anything. We're just trusting too much to these models. And then, as we know, their outputs could be prone to errors. So they actually have some suggestions, and I really recommend you to just take a look at this paper, summarize it, and then go through them. But one of the things that they discuss is that yes, we have moved from doing things to leaving these things to AI for especially simple tasks, but we still have to manage the AI to make sure the outputs are accurate, and at the same time we have to spend time thinking about the results that we'll get from AI. So these are the very important things that we need to do to evaluate and fix how AI generates results for us, or the results generated by AI, without accepting things blindly. There are actually different ways that we can make sure that we're still in a good position, even if the job market in the future would be very, very challenging. And it means that we have to learn new things as much as we can, because the more you know, the higher your chance is to get a job in that market, a very good one, even if it's very, very challenging, very competitive. So these are the two strategies that I myself use, and it has worked quite well for me. So I'm going to start from here and then jump to the encyclopedia reader strategy. So what is ARLI that I use? So ARLI stands for ask. So in case of using large language models or chatbot, is to ask your question, then review the response that you'll get from the AI model. Then if there are things that you don't know, you just learn about them. For example, you ask for more information, you do more research yourself about that concept that you don't know. And then once you learn about the different things needed for that question that you asked and the response that you got, you iterate over and over until you get what you want. And again, in the context of AI chatbots, for example, for generating some code, what I do normally is to ask the AI, this is what I want, these are the considerations, and then the response that I'll get, I review it very, very comprehensively. And then if there are things that I don't know, or maybe there are things that may be obsolete already and I didn't know them, I will just do more research. I will even ask for explanation or more information from the AI. And then after learning about those things, I will iterate over and over, which means that, for example, the AI may have used an obsolete, a deprecated library or API, and I will share the new library or the API with it. And then this means that I iterate to make sure that the final result would be accurate and based on what I had in mind. So this is important. These 4 steps have helped me a lot. And then there is another method that I use a lot, and I call it encyclopedia reader. how does this encyclopedia reader strategy work for me? As an example, again, let's go back to the Rust example. And I want the AI to generate me some AI code, AI-based code in Rust. And then before that, what I would do is to learn as much as possible about Rust. I will go to the documentation, the official documentation. I will very, very quickly read different examples, the APIs, maybe some implementations about more complex things. I would not, have my hands on the keyboard. I will just quickly review things, try to learn in a very, very high level manner, which means that I don't care about details. I just want to get some context about the syntax, about some rules, about how different things that I know in different other languages are handled in Rust. And then when I get some very high level understanding and knowledge about Rust, in this example, I would go to the AI model and then I ask it, hey, I want you to generate this code in Rust for me. Again, these are the rules, these are the considerations, and then it'll do that. And then I will follow the hourly strategy. And then I review it. And because I have a very high level knowledge, which again, I don't know a lot of details until I just learn about them, but I know the structure of the work, then I will review the different parts that were generated. And then if there are parts that I need to learn more to make sure these are the things that would be helpful in that context, I will focus on them and learn more about them. So it means that I go to the learning mode. I will iterate over and over. And I say that, hey, I think that this part or this function that you use in here may not be a good choice because maybe in the future we want to do these things. So I will iterate until I get a more polished version of that code. The third part of this video is about AI tools. There are lots of AI tools, and sometimes, again, just like AI models, it's confusing which ones or which one is actually better. There are two main groups, one of these AI tools. One are the IDEs, integrated development environments, which are mostly based on VS Code, Visual Studio Code, developed by Microsoft. And because Visual Studio Code is open source, you can easily just fork it. You can have your own clone, and then you can add features to it to customize it based on your needs. If you don't know, VS Code is actually based on a web engine, and that's why it's easily cross-platform. And it's based on Electron. So this is a very powerful framework. Try it if you want to develop cross-platform applications. There are different versions of VS Code because it's, again, open source. You can use it, different companies can use it for free. It's under MIT license. The maybe most popular one is Cursor. You can also see their pricing. They have a free version, they have a pro version. So try it. I will test all of these. I personally use Cursor. I have used Windsurf, the new VS Code with the new Copilot, which has agents. And I'm gonna test them, and we're gonna evaluate them for geospatial tasks and see how they work. And there's also the new VS Code plus Microsoft own agents. So it was in beta and I think for 2 or 3 months, and they have recently published it as a stable. I have tested it. It's not bad. It's good, but sometimes I think that it's not ready yet. Compared to Cursor, the new Microsoft Copilot agents are not really competitive yet, but I think that they will because that's Microsoft. And Windsurf also is very much like Cursor, again, another fork of VS Code, and they also have their own agents, and they're also good, but I found the experience working with Cursor to be smoother. But I think at some point they're going to be very much like each other, so I'm going to test all of them in a separate video. And there's also the very interesting and powerful Google Firebase Studio. Is a fully autonomous agentic IDE that, again, just like Windsurf and other AI powered forks of VS Code, you can just ask it what to build for you, and it's smarter and more capable, I think, based on my test, compared to what you can get on Cursor or Windsurf. And it has a great design, and you see that because, again, VS Code is open source and free and under MIT license. Google also have used the online embedded version of VS Code in the Firebase Studio. So we're gonna also try that. And there's also Versal V0. So you can build applications using Versal or Versal V0 platform. And it's using, as far as I have tested, it's using Next.js only, because Next.js was developed by Versal. And there's also Lovable. We're gonna test this one as well for our application. And there's also Devin. Devin is an end-to-end fully autonomous system for building apps. So what differentiates it from the other solutions that we saw is that you ask it to build something for you, it will build it for you, and it doesn't stop at generating only the code. As far as I know, and I have seen it, I haven't tested myself, but it's also doing tests for you, and it's gonna test it, making sure it passes the tests. Again, we have to see. I want to try it. It's kind of expensive, but it'll test it, and then it will just push things to Git, your GitHub or GitLab or any other Git repository, and then you can iterate and polish it further. So that's interesting. The first version, people had some problems with it, but I think the second version they have improved perhaps a lot of things, and they have learned a lot from the experience they got in the first version. So they have two main tiers. The team version, which is $500 per month, it has 250 agent compute unit. This is one of those things those credits that sometimes is confusing. You don't know how exactly they are calculated, but the core tier is like pay as you go, so based on your usage, but it has less I think features compared to the team version. But we're gonna also test it. I really want to test it and see how it works. So these were all the main tools that you see these days. Of course, there are other ones that I'm gonna talk about them later. For example, how to run these tools locally based on your own models. And it's interesting how this area is advancing so fast, and sometimes it's really difficult to keep up with all these new technologies. So the best thing is to try them. Some of these, or not all, are free, so you can try them. And there are also, as I said, tools that we can run locally on our computer for free using these open source models. And in a future video, again, my plan is to record and publish at least 3 videos like this. The next video will be like, we're gonna test some of these tools, and then in a future video, we're gonna, for example, fine-tune 1 or 2 of these open source models on our own data for our own application and see how it works. So, or maybe more videos about other things, but this is important to make sure that we learn something new and we can use them for what we do in the field of geospatial data science. So I hope that you enjoyed this video. Make sure to leave your comments, subscribe, and let us know if you have any questions. And thank you so much. Have a great day. Bye-bye.